Okay, let's talk about the section 2.2, graphs of equations in two variables, intercepts, symmetry. Graphs of equations in two variables. Intercepts. Symmetry. Okay, so let's see. Equation, of course, we have a lot of equations. 2ax plus b is equal to 0. Linear equation. Ax squared plus bx plus c equal to 0. Quadratic equation. And with even more ops value function, like ops value of x is equal to a, the ops value the equation involving ops value function. But all these functions will always claim a, b, c are constant. Only x is a variable, so there's only one variable. So now we are talking about the equation in two variables. Okay, so an equation in two variable say x and y is a statement in which two expressions involving x and y are equal. Okay, so you have two expressions, two expressions. You have left side, right side, two. You balance them, and they are equal. So you put the equal sign, and those two expressions they will involve x or y. Okay, so for example, you have x squared plus y squared is equal to 1. Two expression or two expression. The first expression, left expression is x squared plus y squared. Right expression is 1. In the right hand side, it looks like it does not involve x, y. It's okay because one expression involves x and y. That's enough, and they equal. Okay, so those two expressions, of course, they are placed on different sides. So this is the left side. We will always say the left side of the equation or the right side of the equation. Right? The left side means the left side of a equal sign. And when we have such equation, of course, we will have solution, right? We say any value of values of x and y that result in a true statement are said to satisfy the equation. We want to emphasize the word satisfy. We will say, you see, x equal to 1, y equal to 0. This choice, you put x equal to 1, 1 squared is 1. You put y equal to 0, 0 squared is 0, 1 plus 0 is 1. So left side is equal to right side. So this pair satisfy the equation because it results in a true statement. And of course, you will see that x equal to 1, y equal to 1. If you try this, the left-hand side becomes 1 plus 1 is 2. It's not equal to right side. Does not, do not satisfy the equation. Okay, so that's how we say satisfy or do not satisfy. Okay, so it's like the solution set of an equation. You have a 1, 0. Of course, you will have 0, 1. 0, x is 0, y is 1. This is a pair. Or x is 0, y is negative 1 because you square it. So, or you may even have x is a square root of 2, y is square root of 2 over 2. Both square root of 2 over 2. So you will see that we do have a lot of solutions, right? And because you have a pair, so you can say, okay, let's use the point 0, 1 to demonstrate or to represent this pair. So x is 0, y is 1. So this solution corresponds uniquely to a point in the xy plane. Here the same thing. It is uniquely determined by a point in the xy plane. Here is the square root of 2 over 2. So you may have, for example, 1, 0. X is 1, y is 0. Is here. 0, 1, 0, 1 is here. 0, negative 1, 0, negative 1 is here. And this root 2 over 2, root 2 over 2 is possibly here. So you just get all possible solutions, and then you plot all the corresponding point. Possible solution plus the corresponding point plotting. You will see you get a curve in xy plane. And this curve is called the graph of the equation. Graph is actually the collection of the solution set. Okay, so let's make this definition in detail. Okay, so the graph of an equation in two variables x and y consists of the set of points in the xy plane whose coordinate x and y satisfy the equation. Okay, so you just get all possible stuff and then you plot them, and you more or less like you get sufficiently many solution, then you will see the sketch of the graph. Okay, because you have two variables, you do have x and y, so that fits this xy plane. So we try to use some geometric object to demonstrate the solution set of a two variable equation. So here basically we use some geometric figures to show the solution set of two variable equations. Okay? Okay, let's see. if you check this definition of the graph, you will see that graph is a collection, set is a collection, collection of point, so that the coordinate of the point satisfy the equation. So every point from the graph will satisfy the equation. Every point from the graph satisfies the equation. Every values of x and y satisfying the equation. Okay, then this value gave a point on the graph. Okay, give the point on the graph. Okay, now let's see this is the stuff we're going to use for the example. So determine if the following points are on the graph of the equation two x minus y equal to 6. We need to answer it. Does it satisfy the equation or not? Right? If the pair of numbers satisfy the equation, then it is the corresponding point will be on the graph. If the pair of values does not satisfy the equation, the corresponding point does not lie on the graph. Okay? So first pair is 2, 3. And second pair is 2, negative 2. Well, let's see solution. We're going to examine if it satisfies the equation. So we have no idea if the equation is correct or not. So let's check. X is 2, y is 3. So you get 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. So this is the value after evaluation of the left side is not equal to 6. It's not equal to 6. So this pair does not satisfy the equation. The point is not on the graph of 2x minus y equal to 6. Okay? Not, because it's not equal to the right side. This is A, and B, 2, negative 2. 2, negative 2, let's check. 2 times 2 minus negative 2. Just be careful. 2 times 2 is 4. 4 minus minus is plus. Is 6. Okay? You do have the right side. It says checked. So the point is on the graph of 2x minus y equal to 6. Okay? It's not that bad. All right? So to examine or to determine a point is or not on the graph, you just check if it satisfies the equation. You start from left hand side, and also this is simple, so you do not do anything about right side. So sometimes the left side and right side both involve x and y. So you're going to evaluate left side, you're going to evaluate right side and see those two values match or not. Okay? Okay, good. Example 2. let's see some basic graph. Graph the equation y equal to 2x plus 5. Literally speaking, if we do not use any other advanced tool, we can only plot the graph by evaluation, sufficiently many evaluation. So far, how do we know? I mean, assume you know nothing about the graph of this equation. How do we get the graph? So just list, for example, x is 0. X is 0. 2 times 0 is 0 plus 5. Y should be 5. X is 1. X is 1. 2 times 1 is 2 plus 5 is 7. Y is 7. And then x is negative 1. X is negative 1. This is negative 2 plus 5, 3. X is 2. 2 times 2 is 4 plus 5 is 9. X is negative 2. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. So if you are not satisfied with those evaluations, you can have some decimal number like 0.5, 1.5, negative 1.5, negative 0.5 stuff. But let's see. There's number 9, so it's very tall. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Exit negative 1, positive 1, the positive 2, negative 2, negative 2, negative 1, 0, 1, 2. When x is 0, y is 5 here. When x is 1, y is 7 here. When x is 2, y is 9 here. When x is negative 1, y is 3. When x is negative 2, y is 1. Okay, so once you have those 5 sample points, you always use smooth curve to connect them. You do not draw some weird graphs. Okay, so you see here, it looks like a straight line. So we got a straight line. We got a straight line. The graph of this function is a straight line. It's a line, so that's why we call such function a linear function, because all the lines, all the graphs will be a straight line. If my coordinates are good, so you do have a straight line. Okay, so y equal to ax plus b. Y equal to ax plus b. If you try more examples, you will see that the corresponding graph is always straight line. So later, if you want to draw the graph, how do you do that? You only need 2 points, because 2 points will uniquely determine the straight line. So you let x be 1, you get a point. X be 0, you get another point, and then use a ruler to sketch it. Okay? So this has a line as a graph. Okay. Second, let's graph the equation. Y equal to x squared. Y equal to x squared. Well, we will do the similar stuff like this. X is 0, x is 0, y is 0. X is 1, y is 1. X is negative 1, because it's square, y is still 1. X is 2, y is 4. X is negative 2, y is still 4. X is 3, y is 9. X is negative 3, y is still 9. Okay? So possibly it's not enough, but if we get the next one, we will have x equal to 4, y is 16. 16, you see here, here's 9, 10, 11, 12, 13, 14, 15, 16. It's too high, so let's just use 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, and 3. Negative 1, negative 2, negative 3. Okay, so x is 0, y is 0, 0, 0. X is 1, y is 1 here. X is negative 1, y is 1, this point. It's like you have a mirror. X is 2, y is 4, x is 2, y is 4 here. X is negative 2, y is negative 4 is here. It's always balanced. X is 3, y is 9, so it's here. X is negative 3, y is negative 9. X is negative 3, y is still 9. So if you try to sketch it, let me use a okay, so this is a graph of the function y equal to x squared. And this shape is called a parabola. Well, the name is called parabola. It's like this shape is called a line. We just have a name. All right? So whenever you have a quadratic equation, its graph is always a so-called a parabola. Okay? So always parabola. Okay, so second. So we have the graph. And this one is simple because whenever you have x, you can quickly find the corresponding y value, and then you determine the point on the graph. And sometimes when the equation is extremely complex, it's not that easy to find the graph. Okay, graph, later you have to collect some examples of graphs. And when you have a complex function, in general, we don't have a complete information about graph. Okay, but we don't have complete information. We still want to find some special information. So this is an intercept from a graph. What is an intercept? So assume you have a graph for a certain function like this. Oh, here is the intersect. Okay, so if you have something like this, for example, like this one, the graph of the equation intersect the x-axis, but not go to the other side. This one we call the graph touches. Graph touches the x-axis. Okay, so it's always on one side. So you can touch it from above. You can also touch from below, like this. This is also touch. Well, it's hard to sketch. Okay, this is also touch. And this point and this point, we say the graph crosses x-axis. Crosses x-axis, because the graph will be on two sides of our x-axis. Okay, and here, of course, this graph crosses y-axis. Okay. And whatever graph touches x-axis or cross x-axis or cross y-axis, the points, those points are called intercept. Intercept, this word, intercept. The points, if any, at which a graph crosses or touches the coordinate axis are called the intercepts. Are called the intercepts. So this graph, so far based on the current information, it has 4 intercepts. 1, 2, 3, 4. So we count intercept with the x-axis and also with the y-axis. Okay, so it has 4 intercepts. And the x-coordinate, of a point at which the graph crosses or touches the x-axis is called an x-intercept. X-intercept. Okay, so why? For example, this one, every point on the x-axis is always related to the coordinates x0. Every point, so here, points on x-axis have y coordinate 0. Every point on the x-axis always has y coordinate 0. So you don't worry about the y coordinate. Y coordinate is known. So the important information about this point from x-axis is x coordinate. So that's why if the graph crosses or touches x-axis, we don't record the y coordinate. Y coordinate are always 0. We only record the x coordinate. So possibly this is a -2, +1, +3. We only record the x coordinate and that number. Now you see here, x-intercept is a number. Intercept is a point. Point has x, y coordinate. Okay? Okay, so if it crosses or touches x-axis, the corresponding x coordinate is called x-intercept. If it touches or crosses y-axis, then the corresponding y coordinate is called y-intercept. So let's make it complete. The y coordinate of a point at which the graph crosses or touches the y-axis is called a y-intercept, right? Y-intercept. So that's the definition of intercepts. Okay, let's see one example. Assume we have, let's do it in the next clean paper. Example, find the intercepts of the graph. What are x coordinate, x intercepts, what are y intercepts? Okay, so we are looking for intercept, x-intercept, y-intercept. The graph is provided. Okay, so 1, 2, 3. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, and 1, 2, 3, 4. So it's 1, 2, 3, 4, negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. The graph is like this, so we just you can see the graph in the textbook. We just randomly get a graph. So this point, corresponding point is 3, so it's a negative 3, 0. This is 0, 3. This point, the intersection point, is 3 halves, comma 0. And this is 0, negative 4 over 3. Sorry, 4 over 3. 0, comma, negative 4 over 3. This is 0, negative 3.5. And this point is 4.50. Okay, so assume I have a clear picture of it. This number is 0, comma, negative 4 over 3. Okay, so if you have such graph, then the intercepts, let's see how do we write it. We are going to follow this curve and count them. Otherwise, we cannot know if we completely collect them or not. So first one, you see this point, the graph touches x-axis at the point negative 3, 0. So the intercept, you need record xy coordinate. And then you move to here, this point, the corresponding coordinate is 0, 3. It's on the y-axis. X coordinate is always 0. Y-axis, y is important. X-axis, x is important, right? So y-axis, x is 0. X-axis, y is 0. And then you continue here. It's 3 halves, comma 0. And this point is 0, negative 4 over 3. And then you continue move to this point. It's 0, negative 3.5. And this point is 4.5, comma 0. So this is a comma. It separates x and y coordinate. This is a point 0. A point in the decimal numbers, the different. Okay, so we have 1, 2, 3, 4, 5, 6. We have 6 intercepts. We have 6 points. Then the x-intercept. X-intercepts means we only collect x coordinate. Here, negative 3. This is on the y-axis, so we don't count. This is 3 halves. We only consider the x coordinate. Here 0 is on the y-axis. Here 0 is on the y-axis. Here is a 4.5. Okay, so this is x-intercept, only x coordinates. The y-intercepts, you only count the y coordinate. 3, negative 4 over 3, and negative 3.5. Okay, you only consider the y coordinate here and here, and that's it. All right, so if you have the graph clearly, then you can easily point out the intercepts. Actually, you know more than just the intercept. Intercepts are just some special point, the intersection between the graph and the coordinate axis. And be careful, if you do not put x, y, intercepts has both coordinates. It will have x and also y coordinates. But once you consider just x-intercept, they are numbers. They are x-coordinate numbers. If you consider y-intercept, they are y-coordinate numbers. Okay? Okay, so we finished today's lecture, and we will continue the discussion of intercepts in the next lecture. Thank you very much. We stop it.